Today we're going to look at finding the optimal solution in a feasible region. So what does that mean? Well, let's say that we have a problem, just a problem in math class or whatever, and it's about pencils and erasers. We have so many pencils and so many erasers, or that's what we're trying to figure out anyway, but we're given some restrictions. Let's say we have 4 restrictions or constraints. Well, we need to find all the possible solutions that fit the constraints, and that set of solutions is called the feasible region. So we can see what that looks like here. It's a little bit hard to tell, but there is an area here that's actually shaded by all of the colors. In other words, the solutions that fit all of the constraints, and that area is right there. So this is called our feasible region. Everything inside that red border works. All the solutions there work for all of our constraints. So whatever we're looking for has to be somewhere in there. Which solution is in the feasible region is optimal or best? That's usually what we're trying to figure out. But optimal or best depends on what we're talking about. We might be trying to find the most profit, or maybe we're trying to get the cheapest to create, or maybe we're trying to see which solution will buy the most votes in the next Dominican election. I don't know. It depends on whatever you're being asked. So let's explore this a little bit more. So here we have the same feasible region. We notice that the more pencils we have are over here, more erasers going up over here. So this point right here represents a solution in our feasible region for a possible number of pencils and erasers that work with all of our constraints. So this point right here is the point 10, 6. And we're asked, is that the best? Well, again, it depends on what we're talking about. If we're trying to maximize profit, well, it should be obvious that it's not the best, because it should be better to sell more pencils and more erasers. So if we go in this direction here with our point, we will be increasing profit, because we will be selling more pencils and more erasers. Well, we can keep saying that until we get all the way up to this tip over here. So that point right there is going to represent the most profit, because it's the most erasers and the most pencils. We can't do any better than that. So again, if we're trying to sell more erasers and more pencils, well, the point 14, 12, which means 14 pencils and 12 erasers, is better than the point 10, 6, which was our original point right here, because we're going to make more profit. In fact, 14, 12 isn't just better than 10, 6. It's actually the most pencils and most erasers, so it maximizes our profit. That example isn't that interesting, but let's see if we're trying to minimize this. Let's say we're trying to minimize the cost. Let's start at that same point, 10, 6, 10 pencils, 6 erasers, and see what happens. Well, if we want to minimize cost, that means we want to get fewer erasers and fewer pencils, so we want to go in this direction. But if we go in that direction, we hit this line right there. Could be anywhere on that line, we don't know. Could even be on that bottom line down here, but we don't know. We're going to hit a line somewhere, and we need to see, is that going to minimize the cost? This is harder than the other example where we're trying to maximize profit, because we need to make fewer erasers and fewer pencils. But that point right there, that's the point 6.4. While it is better than 10.6, it is not the least pencils or the least erasers. Sometimes that might be okay, but sometimes not. Let's see what happens here. If we wanted to decrease the number of pencils, we could by going in this direction. The problem is that that also would increase the number of erasers. So is that better or worse? Not sure. What about if we go in the other direction? Well, we're going to be decreasing the number of erasers, but increasing the number of pencils. So is that better or worse? Well, we don't know. It depends. 4.6 is the least number of pencils, but not the least number of erasers. That's up here, right? 7.3 is the least number of erasers, but not the least number of pencils. That's this point down in the lower part. Well, so what's the answer? Well, it depends on how much the pencils and erasers cost. So we have to know how much they cost. If the pencils cost 10 pesos and the erasers cost 15 pesos, right? The pencils are cheaper and cheaper by at a certain ratio. So you could figure out that this point where there are 4 pencils and 6 erasers would be more expensive than the point down here where there are 7 pencils and 3 erasers. On the other hand, if erasers were more expensive, we would see that if pencils cost, let's say, 10 pesos and erasers cost 7 pesos, then going this direction would be better. We would have less cost here at 4.6 than here at 7.3. How do I know that? Well, I could figure that out very easily because I know the price of erasers, or the cost of erasers and the cost of pencils, and I could just plug in the point 7.3 and plug in the point 4.6 and see which is cheaper. So, what did we learn here? Well, what we learned is when you're finding the maximum or minimum in a feasible region, you only need to test the corner points. But why? Well, because the middle region can't be best. If we're somewhere in the middle, it will always be better to get one direction or the other. Maybe increase both of them or decrease both of them or something like that. So we can always do better than in the middle. So let's X that out. We don't care about the middle. Similarly, if we get to one of the borders, it's always going to be better to move one direction or the other direction. If we hit this border, it would be better to go in that direction or in that direction, up or down. It just depends on what we're looking for, what we're trying to maximize or minimize. So the border lines are out except for at the corners. The only thing remaining are the corners, because if you move in one direction, eventually you will hit a corner point. So the corner point is going to be the best that we can do. So you only need to test the corner points when you're trying to maximize or minimize and looking for a solution within your feasible region.